Hello everyone and welcome back to Fizan IT. In today's video, we're breaking down the difference between omnidirectional and directional antennas, and we'll focus on specific types of antennas like Yagi and Parabolic. Antennas are vital for effective communication, whether that's for your Wi-Fi at home or for professional broadcasting. And today we're going to explore the use cases and the types of antennas. So let's get into it. The first type of antenna we have is omnidirectional antennas. These antennas emit and receive signal in a 360-degree pattern, making them perfect for general coverage areas where the signal direction varies widely. They are similar to a lamp that lights up an entire room, so that's one way you can think about it. It's commonly found in home environments, like in a Wi-Fi network at your home, and is very convenient for general use. And as you can see in this picture that I have drawn, that you can see that there's an access point in the middle, and as you're closer to the middle of the access point, the signal is stronger, and as you get further away, it gets weaker and weaker, and it's a 360-degree coverage area. Next up, we have directional antennas. So these antennas are focused on giving signal in a specific direction, allowing them to reach further distances. As you can see in the picture, we're using two antennas to connect two buildings together when the distance is quite far away. This is where we would use a directional antenna rather than an omnidirectional antenna. And they also must be precisely aimed to ensure the best signal quality. And as you can see in the picture, I'm using a Yagi antenna to connect these two sites, which I'll explain when we get into the next slide. So now we have two different antenna types, and these are known as directional antennas. So the one image on the right is called a Yagi antenna. So this antenna is a directional antenna that consists of multiple parallel elements in a line, usually including a reflector and one or more directors. They focus a signal in one direction, enhancing reception and transmission over longer distances. And the image to the left is a parabolic antenna, which are highly directional and resemble a dish-like shape. These antennas use a parabolic reflector to direct the energy into a single feed horn, as you can see right here, and this allows for high gain and long distances for signal to focus, making them ideal for something like satellite communication or radar systems. I want to quickly go over the concept of polarization. Polarization is the orientation of a wave as it travels through space. We have vertical polarization, where the wave travels vertically, and we have horizontal polarization, where the wave travels horizontally. Both sending and receiving antennas must have the same polarization to ensure optimal performance. If there's a polarization mismatch on the sending and receiving side, only half of the signal will be received, or in some cases, it may be even less, which is why it's important to understand what polarization is, so if you set up your own antennas, you don't make this mistake. So now that we have discussed Omni, Yagi, Parabolic, directional antennas, which one do we use? So choosing between each antennas all depends on your needs. Omnidirectional are great for broad coverage with less range, for example, a home network, right? Yagi antennas are excellent for targeting distances or specific areas. For example, if you're trying to connect two buildings together that are maybe a couple kilometers away, a Yagi antenna might be sufficient. If you're going to have satellite communication, parabolic antennas offer very high precision and are fantastic for satellite communication because they can go for very long distances and they're very focused. So when you choose antennas, it all depends on your needs and what you want.